Welcome back to Miss Eddie's Math Movies, where it's cute to be a square. Today's lesson is 7.6 dilations. By the end of the lesson, you'll be able to identify and draw a dilation. A dilation is a transformation. We've talked about lots of transformations. We've talked about reflections, rotations, and translations, and now we're doing dilation. A dilation is a transformation with center C and scale factor, we've talked about that word before, that changes the size of a figure. Right? So we're getting bigger or smaller. So reduction is when the image is smaller than the original. Just like if the price is reduced, it's getting smaller. An enlargement is when the image is larger than the original. All right, and so our scale factor, which is K, if it's a reduction, it's going to be less than 1. If it's enlarging, it's going to be greater than 1. And if it's equal to 1, it's not going to get bigger or smaller. So less than 1 is a reduction. Greater than 1 is an enlargement. So we're going to look at some different dilations here. And one thing I want you to write down is about the scale factor. To find this scale factor, write this down. K is equal to CP prime over CP. All right, and we'll talk about what that means in a second. But remember, when we do transformations, we always go from P to P prime. So we start at the original, we go to the prime. And we'll talk about what that means in a second. So look at these dilations. We have to know whether it's a reduction or an enlargement. So I want to kind of show you what we're looking at here. Look at the regular letters first, P, Q, and R. So this is our original because those are regular letters. And then this orange triangle is our image. That's where we are ending up. So we ask ourselves, are we getting larger or smaller? Well, if we start with this green triangle and go to this orange triangle, that is definitely an enlargement. All right, let's look at this one. Here's the original. Here's X, Y, Z. See this large green triangle? And then X prime, Y prime, Z prime is where we're ending up. So we are definitely getting smaller. That is a reduction. So make sure you're always starting with the original and going to the one with the apostrophe. That's how you tell if it's an enlargement or a reduction. Find the scale factor of the dilation. Okay, so let's check this out here. We're starting with this green triangle. That's the original because see there's no apostrophe. Then we're going to this triangle. All right, in order to find the scale factor, I had you write that down earlier. You're going to do CP prime over CP. Remember, C is the center, so that's kind of like where we're enlarging or reducing what we're going through. So CP prime goes on top. So the distance from C to P prime goes on top. So C to P prime is 2. We put that over the distance from C to P, which is 3. So the scale factor here is 2/3. Over here, we're starting with this green diamond shape, and we are ending with this orange diamond shape because that has the apostrophe. This is the center we're going through. And now we're going to find the scale factor. So the length of CP prime, C all the way to P prime, is 6. C to P is 3. And 6 over 3 is 2. So our scale factor here is 2. In example 2, tether whether the dilation is a reduction or an enlargement. Give 2 ways to support your answer. So A, we're going from regular to prime. We're definitely getting smaller. This is a reduction. And we know this because the image is getting smaller. And another way is smaller. Another way is if we look at the scale factor. The scale factor is 2/3. 2/3 is less than 1. If you remember, a reduction has to be less than 1 because it's getting smaller. Look at choice B. We're starting with this green diamond and going to this orange diamond. Well, we're getting bigger. That is an enlargement. Because the image is larger. Another way of knowing is look at our scale factor is 2. And 2 is greater than 1, which is what an enlargement has to be, is greater than 1. Tell whether the dilation is a reduction or an enlargement. All right, so that's what you have to do. Is it a reduction or enlargement? And then you have to give the scale factor. And remember, that's CP prime over CP. So that's what you have to do for each one. So go ahead and do these now. Remember that you're going from P to P prime. P prime, Q prime, R prime is the image of PQR after a reduction. Okay, so we started with this triangle. And then we end up at this triangle. It's telling us it's a reduction. Yep, looks like a reduction. We're definitely getting smaller. It says write a proportion. Okay, so let's look at the proportion. If these are similar, we can write a proportion. Well, let's look at what we have here. We know, let's see, x and 14 go together. You see they're going to the same triangle. So I'd probably write a proportion like that. X is to 14 as, so x and 14, well, x goes with 6, 14 goes with 8. So that's one proportion you could write. There are others. Well, you could use the scale factor, CP prime, which is 8, or CP, which is 14. So 8 is to 14, so we did smallest to large, is small is to large. So there's another option that you could do. Or, so you could do x is to 6 as x is to 6 as 14 is to 8. Any of these equations are fine. They're going to give you the exact same answer. So they are doing, I'll show you the equation they used. QR prime to R prime. So they did this middle equation here. They did 8 is to 14 as 6 is to x. So you can pick any, right? Then we cross multiply. We end up with 8x is equals 6 times 14 8 times x is 8x, 6 times 14 is 84. You have to divide both sides by 8, and we end up with x equals 10.5. All right, so you're going to say, all you have to do is write a proportion, just like we've been doing before. So I want you to do this checkpoint now. You're going to write a proportion and solve. This is M cubed signing out.